The central question is simple. Can software change the electrical state of a physical pin? On a Jetson Orin Nano, the answer is yes. A Python program can tell a GPIO pin to go high or low. That sounds small, but it is the real bridge between software and hardware. Once a pin changes state, code is no longer just information. It has begun to affect the physical world. A pin is a physical metal connection on the board, but behind that pin is configurable circuitry inside the chip. If the pin is configured as an output, the Jetson can drive it high or low. High means roughly 3.3 volts. Low means roughly 0 volts. So when Python changes the output state of that pin, it is changing a real electrical signal. The Python side is straightforward. The Jetson GPIO library lets the program choose a numbering mode, configure a pin as an output, and then drive that pin high or low. In code, the basic setup is small. Choose board mode, set the LED pin as an output, then call GPIO.output with either high or low. That is the software heart of the system. The pin does not directly power the final output in this design. Instead, it controls a transistor. The transistor acts like an electronic switch. A small GPIO signal goes into the transistor base through a resistor. The transistor then allows current to flow through a separate LED circuit. So the Jetson pin is not doing the heavy work. It is controlling the switch that does it. The LED side of the circuit is also simple. A 5-volt supply feeds a resistor, then a red LED, then the transistor, then ground. When the transistor is off, no current flows, and the LED stays dark. When the transistor turns on, current flows through the resistor and LED, and the LED lights. That is the moment where a software decision becomes a visible physical result. Now add the camera. A USB camera looks at the scene and captures frames. In the first version, there is no AI model. OpenCV simply reads the camera frame and checks whether there is enough red in the center of the image. So the first practical goal is not advanced intelligence. It is a reliable yes or no answer to one simple question. Do we see a red cap? OpenCV handles the image step. The program opens the camera, reads a frame, converts the center crop from BGR to HSV, then creates masks for red. It counts how many red pixels appear in that center region. If the red ratio crosses a threshold, the code treats that as red detected. Then the logic becomes very simple. If red is seen, set the LED on. Otherwise, turn it off. So the complete loop is this. The camera sees a red cap, the software detects red, Python sets the GPIO pin high, the transistor switches on, and the red LED lights. That is why this topic matters. It removes the fog around hardware control. Software is not magically commanding the world. It is changing the state of a pin, and that electrical change propagates outward into a real circuit.